Hello everyone, welcome back again to Mastering Retaining Walls and Shoring Systems using Plaxis 2D. This is tutorial number 11, simulation of cantilever retaining wall using plate element in Plaxis 2D. If you remember, in all previous examples, we simulated different types of retaining wall, like a gravity retaining wall and cantilever retaining wall, using a volume element. So we modeled like a soil polygon, and after that we define the material for the concrete or masonry wall, and after that we assigned the material to this volume element, and it was representing cantilever or gravity retaining wall. So the problem in the volume element, we cannot see the forces in the structure, like the bending moment, shear force, and axial force, and these forces are very important in the retaining wall, because for example, if you have a reinforced concrete cantilever retaining wall, we need to know what is the maximum bending moment in the wall, so we can use these forces to calculate the reinforcement and rebars for these walls. So the purpose of this example, we will use a plate element approach instead of a volume element. Also, when we define, for example, a foundation or retaining wall in Plaxis 2D, we need, using a plate element in Plaxis 2D, we need to calculate the flexural rigidity, which is E times I, and also normal stiffness for the structure. So these are the input values should be inputted into the software. Also, we will see when we simulate the retaining wall using a plate element, we can see the forces in the element, like a bending moment force and shear force and axial force, etc. Okay, so this is going to be our example in this tutorial. As you can see, we have a two soil layer. The bottom soil layer is a dense sand, and the upper soil layer, which is has a ground slope, is a clay soil. And also we have a retaining wall in here, and we have modeled it using a plate element. And after construction of a retaining wall, we will fill behind the retaining wall with a backfill, which is a medium sand, and after that we will apply some surcharge load. So as you can see, this is a domain of our problem, and the first soil layer is or the bottom soil layer is a dense sandy soil, which is 15 meters, and the upper soil layer is a sloped ground clay soil layer. In the right side it is 16 meters, and in the left side it is 10 meters. Also the boundary in X direction is 50 meters, and we will use the coordinates like this one in Plaxis. So we assume the original point is this one, and you can see the other coordinates as well. So after that we will construct this cantilever retaining wall, and the top of the foundation of the retaining wall is 0.6 meters below the ground surface, and it's 1 meter away from the top of the slope. So as you can see in this example, the foundation of the retaining wall is under the natural ground. It means we have excavation, and after that we build the foundation of the retaining wall. You can see this is a volume element, but I just draw to for explanation. We will model it as a plate element in Plaxis 2D. After construction of a retaining wall, we will fill the backfill behind the retaining wall and 1 meter in front of the retaining wall, and after that we will apply a surcharge, a load, and we will analyze the problem. So we can start in Plaxis right now. We can start by drawing this geometry in Plaxis 2D. So first I will click on Plaxis 2D program.